Dear students, Assalamu alaikum. Today we are going to discuss the trigonometric function. In relations and functions, we discussed about the functions, and what is meant by a function. Now here we will consider the special function, that is trigonometric function. Now if we consider a circle with radius r equals to 1, means radius of the circle is 1 unit, and let P of AB is any point on it. Here we have the circle, its radius is this r equals to 1 unit, and this P of a b, because it is the circle in plane, so this means that any point in plane is of the form of x comma y. Hence P of a b equals to this, the coordinates of this arbitrary point are a and b. Now here point A and this point P coordinates are x, and x equals to a and y equals to b. This means that when we draw a perpendicular from this point P on the x-axis, from this foot of perpendicular up to a distance is a units, and the length of this perpendicular is b, because this means the coordinates. So join this P with O, so we get this right angle triangle by Pythagoras theorem. Hypotenuse square, that is OP square, equals to base plus perpendicular square, that is a square plus b square. Here radius is always 1, which implies that a square plus b square equals to 1. Now if we consider any arbitrary circle with radius equals to r units, or non-unity circle, that is that circle whose radius is not equals to 1, then we may consider, or we will get here a square plus b square equals to r square. Here for simplification, or for this simplification, we will consider, or we consider here r equals to 1. Otherwise you can consider r equals to r units, that is radius equals to some. Now let a, b, c and d be the points, as these x-axis and y-axis touches this circle. That is, a is the point on the positive x-axis, b is the point on positive y-axis, similarly c on negative x-axis, and d on the negative y-axis. Clearly from AO, distance is 1 unit, or distance is r unit. Here we consider circle equals to for this circle radius is 1, so this means that here a equals to 1 unit, distance between O and A is 1 unit, hence the coordinates are 1 comma 0. So the coordinates of this point, that is point A, are 1 0. Similarly coordinates of point 0, this B, are 0 comma 1, because x-axis is 0, y-axis is 1. Similarly point C, negative x-axis minus 1 0, and for D the reciprocal of this, that is 0 comma minus 1, or the. So these are the coordinates. Now let AP, here AP, we have this arc AP is arc. Let us assume, or let's suppose that its distance is x unit. Its distance is x unit. When its distance is x unit, then we know that by the definition of angle subtended at the circle equals to, and angle subtended by this arc at the center of this circle is angle AOP, and this equals to, by definition, length of arc upon the radius. Here length of arc is x and radius is 1, which implies that the measure of this angle in radians equals to x radian, Now if we define, let us define, because we have two types of coordinates for a point. One, the polar coordinate; second one, the Cartesian coordinate. Cartesian coordinates are simply x and y. Polar coordinates are cos theta in terms of cos theta and the sin theta. So let us define a equals to cos x and b equals to sin x. If we consider the radius of circle to be r, then here we have to define a equals to r cos x, b equals to r sin x, r sin x. Now here we are considering r equals to 1, so let us define a equals to cos x and b equals to sin x. Then from first, cos square x plus sin square x is 1, or a square plus b square equals to 1. Here this x is arbitrary. It's the length of this arc AP. We can have the point P in the second quadrant. This means that on this quadrant we can have this point on this or here. So this means that this x changes. This x changes. When it x changes, so we can take it any real number. You studied sin square plus cos square theta equals to 1 in 10th, but theta in that class theta was simply, or you studied there theta to be only acute or the obtuse angle. Here x is anything, x is any real number. It may be positive or it may be negative, or it may be greater than the acute angle or the obtuse angle. So this means that every for any x, cos square x plus sin square x is 1, or a square plus b square equals to 1. Now here these coordinates a equals to 1 0, b equals to 0 1, c equals to minus 1 0, and d equals to 0 1. So this means that here the angle subtended by these points with the center and with or this arm OA, that is this initial line, or simply pi by 2. Here this angle is 90, this angle is 180. 180 is 2 times 90, that is 2 pi by 2. Now the third one is 270. 270 is 3 pi by 2, and this fourth one is pi 2 pi, which implies that all these angles are simply the multiples of 90, that is multiples of pi by 2, integral multiples of pi by 2. Now any angle which are of such type, or the angles which are multiples of pi by 2, are simply called as the quadrantal angles. So these are the quadrantal angles. Now at this point A, coordinates are 1 comma 0, 1 comma 0. Here if we consider the angle between OA and OA, it is simply 0, because here x is 0. When x is 0, which implies that the angle equals to 0 radian, a equals to 1, b equals to 0. So but we define a to be cos x and b to be sin x, which implies that a equals to 1 implies cos x is 1 and sin x is 0. Hence cos 0, because x is here at this point, x is 0, which implies that cos 0 is 1 and sin 0 is 0. So at this point the value of this cos and sin is 1 and 0 respectively. Now add b, x is 90, because it is the quadrant angle, and the coordinates of point B are 0 and 1, which implies that cos 90 is 0 and sin 90 is 1, because x is 90, a is cos x, and b is sin x, while a is 0, b is 1. Similarly, we can define at point D, C also, and at D x is 2 pi, because this is a complete angle like this. It's a complete angle. So this means that at point D, coordinates at point this point, again at point this A, because when we repeat the process from this to this, so this means that at this point, here it is A, at this point angle is 2 pi, coordinates are same. So this means that when we from a point, if we complete one revolution about this point, then the value comes out to be same. Only one thing changes, that is the angle. Here at A, initially at A, coordinates were 1 and 0, but the angle was simply 0. But when we make one revolution around this point A, coordinates remain same, that is 1 0, but the angle varies, but the angle changes. from 0 to 2 pi. Similarly, if we do two rotations or two revolutions around this, the angle gets changed. So angle is simply 0 plus 2 pi plus 2 pi. Now if we consider 3, it is 0 plus 2 pi plus 2 pi plus 2 pi. So this means that at this point, again at point A, cos 2 pi equals to 1 and cosine 2 pi equals to 0. Now if we consider third means third revolution around this, it is 2 pi plus 2 pi plus 2 pi, so it is 6 pi. Now fourth revolution means 4 multiple of this 4 times now if we consider the third revolution, at third revolution angle is simply 6 pi. At fourth revolution around this A, angle is simply 4 pi, 4 n pi. So this means that if we consider x equals to 0 and x equals values are same, in nutshell, in general, we can say that the value remains same. Now if we consider x equals to 0, value remains same, and the value is, that is sine 0. Similarly for cos 2 and pi plus minus x equals to cos x. This means, because if we consider here the point, here we have the point, suppose B, here the angle is x. If we consider one revolution, the value is same, so it means that it is 2 pi. Now if we consider around this second revolution, it is 2 pi plus 2 pi, that is 4 pi. So simply we can say that 2n pi plus minus x. If we add or subtract any revolution from a given point, the value remains same, where n is integer, like this. Similarly at point A and C, the sign is 0 because y coordinate is 0, which implies that, but at these 2 points angle is different, and angle is 0 and angle is 2 pi. Similarly angle is pi, but if we consider angle 2 pi, if we consider angle 3 pi, 4 pi, 5 pi, everywhere x is this sin x is 0, hence we can say that x equals sin x is 0 only when x equals to n pi. Similarly for cos, at quadrantal angles at B and D, the value, the y coordinate is 1 and minus 1, which implies that at cos x equals to 0 implies that x equals to odd multiple of pi by 2, means pi by 2, 3 pi by 2, 5 pi by 2, 9 pi by 2, so on and so forth. These functions are simply called as the trigonometric functions. From these functions we can define, the rest for trigonometric functions as tan x equals to sin x upon cos, cosec x is 1 upon sin, cot x is cos x upon sin x, sec x is 1 by cos, and here you defined sin and cos for each and every value of x. So this means the domain of such these two functions is simply set R. But we define these four functions as the quotient of these functions, so we have to define the domain. Here is for this tan, domain is defined where the denominator is not 0. Now the denominator is 0 only when x equals to n 2n plus 1 pi by 2, that is odd multiple of pi by 2. So this means that domain equals to, for tan, domain is completely R, but except odd multiples of pi by 2. Similarly cosec, its domain is removing x equals to n pi, that is multiples of simply pi from R. And for cot and cosec, you know how to define the domain. You know that sin square x plus cos square x is 1 for each and every real. Similarly, you can define 1 plus tan square plus 1 plus tan square x equals to sec square x, and 1 plus cot square equals to cosec square x. In 10th, you studied only x, 1 plus tan square x equals to cot sec square when x is acute or the obtuse angle. Here you define, here the domain of this sin function, this tan function is completely or except 2n plus 1 pi by 2. So this means that this 1 plus tan square x equals to sec square x is valid for all such points except 2n plus 1 pi by 2. So this completes the trigonometric functions. Inshallah, in tomorrow's video lecture, next lecture, we will discuss the signs of these functions. So thank you.